Mechanics chapter 4. So we'll go through basics quickly and then we can come to practice questions. Dynamics of mechanics, particles in motion in straight line, and few prerequisites which we covered in chapter 3. Learning objectives would be draw force diagrams. That's an easy task. Understand the use of Newton's first law. Object at rest will remain at rest and in motion will continue its motion. Calculate resultant forces by adding vectors, exactly like the one we covered in chapter 3. IJ forms. Understand the use of Newton's second law, F equals ma, where F is net force given mass and the acceleration of the object. Newton's second law of vector forces and acceleration. Solving problems involving connected particles, we'll solve them soon. Understand the use of Newton's third law, solve problems involving pulley. Then we'll skip this. This is the prior knowledge we just covered in chapter 3. Addition of vectors using Pythagoras theorem and simplifying. So first basic thing is force diagrams. For example, we have a brick and I say that two boys are pulling that brick, one with 2 Newton force and the other with 3 Newton force. So if you have to just summarize it and draw the resultant, we can say that it is a net force of 5 newtons towards right. Another example, if you have a brick, one is pulling with 2 newtons, the other is pulling with 3 newtons, and the third one is pulling towards left with 12 newtons. So the resultant would be a brick 5 newton towards right, 12 to left. So overall that is 7 newtons to left. If we are drawing arrows, that is enough. If we are just writing the answer, I can say -7. -7 would mean that it is moving to left hand side once I have considered towards right as positive. So worked example as shown, W is the weight, F is the friction in this case, P is the pulling force, and R is the normal contact force on the object by the surface. For example, if I place a book on the table, this is the book and the weight of the book, let me say it is 6 newtons. So the normal contact force upwards would be 6 newton as it is in equilibrium. So upward equals downwards and left equals right. Example question, draw a force diagram to represent the resultant forces. So we can see this is 20 to left and 20 to right. So net in horizontal is 0 and 30 upwards, 10 downwards. So net is 20 upwards. So this is my resultant diagram. Describe the motion of the particle. If I see this diagram as a resultant, I know that net force is upwards. So if there is ever a net force, F equals ma. If net force is there, that means the object is accelerating. So the motion of particle is, it is accelerating upwards. So practice exercise and let's see. We have exam style question. There was not any. So just quickly, let's get done with this, the one with longer statement. Each diagram below shows the forces acting on the particle. Work out the size and direction of resultant force. So I'm solving this A part, resultant force. Left and right both are equal. So no horizontal net force, but there is a net force of 20 newtons upwards. So this is done. In case of B part, up and down is equal. 5 to left, 25 to right. So that is a net force of 20 newtons towards a right. And describe the motion. Definitely having net force, it is accelerating in the direction of resultant force. Question number 13. A truck is moving along the horizontal level road. The truck's engine provides a forward thrust of 10,000 Newton. So an estimated diagram, if it is providing a forward thrust of 10,000, it should look like this. The total resistance in model is constant force of 1600 newtons. that should be backwards. So 1600 newtons. Model the truck as particle. Draw the force diagram to show the forces acting on the truck. So if we just consider this as particle, we can draw it like this. So 10,000 and 1600 newtons in the directions. Then it says calculate the resultant force. So 10,000 minus 1600 and we are left with 8400. So it is 8400 newtons towards right. Forces and vectors, exactly like the one we covered in chapter 3. For example, we are given with forces. The forces 1, 2, 3 and AI plus BJ act on the object which is in equilibrium. So we have 4 of these forces. If that is in equilibrium, that means net force would be equal to 0. So we just add these and equate it with 0. So there you go, 1, 2, 3, 4, add all the I, that is 2I plus 4I, 6, 6 minus 3 is again 3, 3 plus A should be equal to 0. So 3 plus A equal to 0 and we find A. Same way we find B. Another example, in this question, I represents the unit vector due east, J represents unit vector towards north. A particle begins at rest and at the origin 0, 0 is acted upon by 3 forces 1, 2 and 3. Find the resultant, so we'll just add them. I see 2I, 3I is 5, minus 1 is 4I. When we deal with the J part, that is 1 minus 2 minus 1, minus 1 plus 4 is 3, so plus 3J. So I have this resultant. This would be 4 in X direction and 3 in Y direction. So this is the final force having a resultant. Find the resultant of the force, simple Pythagoras theorem, and we'll get 5. Work out the magnitude. Sorry, this is the resultant and then 5 is the magnitude. Describe the motion of the particle. It is a net force. So the particle is accelerating in the direction of resultant force, which is done in part 1. Exercise question, skipping this is simple addition. Let's see question number 3. It says the forces A to B, this is the X part, this is the Y part, or I and J. So first force, second force and third force act on an object which is in equilibrium. Find the values of A, B and C. So if it is in equilibrium, that means horizontal sum is equals to 0, vertical alone is equal to 0. So when we add these 3, which are horizontal, A minus 2A plus 3, that should equal 0. Simplifying, this becomes minus A equals minus 3. So A is equals to 3. For B part or the J component, 2B minus B minus 4 equals to 0. This is B is equals to 4. Values of A and B. Question number 5. In this question, I represents the vector due east, J represents vector due north. A particle is acted upon by forces 1, 2 and 3 forces are shown. For part A, work out the resultant. We simply add them. Minus 2 and 5 is 3, 3 minus 1 is 2I. For J, J plus 2J is 3, 3 minus 4 is minus 1, so minus 1. So this is the resultant vector. Then the magnitude, simply apply Pythagoras theorem. 2 squared plus 1 squared whole square root is square root 5. That is the magnitude, the bearing of the resultant vector. So we know this is 2I and minus 1. So positive 2 and minus 1 is downwards. So I can find this angle theta, which is tan theta is equals to perpendicular over base, and theta is equals to shift tan of 1 by 2, that is 26.6 degrees. Now for bearing, we know we have to go all the way clockwise till this line. This is 90, that is 26. So 26.6 plus 90, you get 116.6 degrees. That is the bearing. Okay, these are the exam style questions. Question 9. A particle is acted upon by forces F1, F2, and forces are given. F1 is given, F2 is given, where A is a positive constant. Find the angle between F2 and I. I is purely in x direction. So in x direction, that is I, and F2. You see, it is A times I, whatever it is, that is, let us consider 1 unit in x direction, because that's A, and it is 2A is 2 times in y direction. So angle between F2 and I, this is the direction for F2. So height is 2, that is 1. So tan theta is equals to perpendicular over base theta is equals to tan inverse of 2. So shift tan of 2 is 63.4. So angle between F2 and I is 63.4 degrees. The resultant of F1 and F2 is R. Given that R is parallel to this, find the value of A. The resultant of F1 and F2, for the resultant we need to add them. So when we do that, this is 3I plus AI makes it 3 plus A in I direction. For J, this is minus 2 and 2A. So 2A minus 2 in J direction. Resultant of F1 and F2 is R. So this is equal to R. And it is given that R is parallel to this. So if it is parallel, this right here says X is 13 and Y is 10. So whatever this is, let us say that it lies right here. Before we know the value of A and B, we cannot say that R is actually longer than 1310 or shorter than that. But what we do know is they are parallel. And if they are parallel, I can say for ease, let me say that R is unknown times H times, and let me name this vector as capital G, is H times G. H could be anything. And now R is 3 plus A and 2A minus 2 is equals to H times, and G is 13 and 10. If you can see, we are now going to make these equations. So the equation in x direction would be 3 plus A is equals to 13H, and equation in y direction is 2A minus 2 is equals to 10H. Now we solve these equations simultaneously. I'm going to multiply the first equation with 2 or minus 2 directly. So that makes it 2, 3 times minus 6 minus 2A is equals to minus 26H. And copying the second equation as it is. Now adding them. When you add them, you get rid of A. This is minus 8. On the other side, that is minus 16H. So H is equals to 1 by 2. Once I know that, substitute it any of the equation and get the value of A. So 10 into 1 by 2 is 5. Take 2 on the other side, 2A is equals to 7. So A is equals to 3.5. So when we know A, we now know what R is. So A is 3.5. 3.5 plus 3 is 6.5. And 2 into 3.5 is 7 minus 2, 5. So for the value of A, that's done. I'm sorry, I've just mixed the two questions up. The question 9 is complete here. Any confusion? 4.3 forces and acceleration. Now all the concepts are same with the addition of F equals ma. Whatever we did for force stays same, mass would be given, and we can find the acceleration. Newton's second law, net force creates acceleration. Example, what is the acceleration of the particle? Mass is given, force is given. Straight away just plug in the formula and we get the answer. Example 6, in each of these diagrams the body is accelerating as shown. Find the magnitudes of the unknown forces x and y. Okay, they are already accelerating. So acceleration is given, mass is given, F equals ma, and direction of acceleration is given. So forward force, x must be more, that is why 2 meters per second square is towards right. So forward minus backward, that is net force, is equals to m into acceleration. So we solve for it, and that is 4 plus 4, 8 newtons is the net force. So x is 8, and for y, because it is not accelerating in the direction upwards, should be equal to downwards. So y is equals to 2g. And value of gravity is 9.81. And we are taking 9.8 only. Examples and exercise. Find the acceleration when the particle has mass of 400 and net force is 120. So F equals ma, force is 120, mass is 400, and we can find the acceleration 120 by 400. Look at this question number 5. In each scenario, the forces acting on the body cause it to accelerate. Find the magnitude of unknown. It is accelerating upwards. That means P is the forward force, and greater force minus 2 into G, that is 2 into 9.8. Downward force is equals to M, that is 2 into acceleration, that is 3. So P is equals to 2, 3 times 6 plus 9.8 into 2 is 19.6 plus 6, we get 25.6 newtons. In this case, we just have 3. It is downwards, so 4g is the greater force. 10 is also downwards, and P is upwards, is equals to ma. So we can solve for P. Exam style question, question number 9. A lift of mass 500 kgs is lowered or raised by means of metal cable attached to its top. The lift contains passengers whose total mass is 300 kgs. Okay, mass of lift is 500, passengers is 300. The lift starts from rest and accelerates at a constant rate, reaching a speed of 3 meters per second after moving a distance of 5 meters. So find the acceleration of the lift. So equation is right there. So v square minus u square is equals to 2as. Final velocity is 3 given in question. It starts from rest. Initial velocity is 0. 2, acceleration is unknown, and it covers a distance of 5 meters. So 3 square is 9, to 5 times 10. Acceleration is 0.9 meters per second square. B part says the tension in the cable if the lift is moving vertically downwards. Now consider this lift. This is the tension. This is the cable. Masses are downwards. 500 of lift, 300 for the person. Total 800 kgs is downwards. I'm writing it as 800 G. Now see that F equals ma. It is moving downwards, so we take 800 G as positive. This is 800 into 9.8 minus tension is equals to mass is known, which is 800, and acceleration is unknown. Acceleration is 0.9. Let me just confirm this. Okay, the acceleration is 0.9. Only unknown is now t. So we solve for t. On right hand side, 800 into 0.9 is 720. On left side, 800 into 9.8 is 7840. minus t. So we rearrange, we take t on the other side, and 7840 minus 720 is 7120 newtons is the tension. C part says tension in the cable if the lift is moving vertically upwards. So same scenario, let me clear this space. Acceleration is 0.9. So C part says find the tension in the cable when the lift is moving vertically upwards. So if the lift is moving upwards, this is tension, this is 800 G. Now the consideration is that upward force is more. So T minus downward force, that is 800 into 9.8 equals MA. Mass is 800, 500 for lift, 300 for people, and acceleration was 0.9. So T is equals to, this goes on the other side and gets added with that, which was already there, 7840 plus 720, and the tension is 8560. So when the lift is going up, the tension is 8560. When the lift is coming down, the tension is 7120. Clear? Okay, motion in 2 dimensions. This is basically the same thing. They are concerned with x and y direction. A quick example. In the question, I represents the unit due east, J represents due north. The resultant force is given x 3 units and y 8 units. Act upon a particle of mass 0.5 kg. Find the acceleration of the particle in this form. So we have F equals ma. Force is given in question, that is 3I plus 8j. Because he asked in this form, that is why we are using this, or else we would have applied Pythagoras theorem. Mass is given, which is 0.5, and acceleration is unknown. So we just divide with 0.5 on the other side. 3 by 0.5 is 6, 8 by 0.5 is 16. So that is the acceleration. Second part says find the magnitude and bearing of acceleration. So straight away apply Pythagoras theorem. 6 square plus 16 square whole square root. We get 17.1 meters per second square. And for the bearing, we draw our plane, and this is positive, this is again positive, 6 in x and 16 in y. We apply tan theta is equals to perpendicular over base, and theta is 69.4. This is 69.4, and for bearing, you know that we have to go clockwise. So 90 minus 69.4 is 0 to 0.6. Always give answer in 3 digits before decimal in case of bearing. Let's see what the exercise has. In all the question in the exercise, I represents this and J represents due north. A resultant force of I plus 4J acts upon the particle of mass 2 kg. Find the acceleration of particle in this form. Again, F equals ma. Force is given, I plus 4J is equals to mass is 2, and acceleration is unknown. So we divide with 2 on the other side. 1 by 2I plus 2J is the acceleration. Find the magnitude and bearing. Magnitude is 1 by 2 squared plus 2 squared whole square root. Use of machine 0.5 square plus 4 square root. Answer is in decimals, that is 2.06, and exact form is square root 17 by 2. And for the bearing section, horizontally is 0.5, vertically is 2. So tan theta is equals to 2 by 0.5. So shift tan of 4 is 75.96. So I'm writing 76 degrees. This is 76, and bearing is 90 minus 76. That is 14, but we write it in 3 digits. So 014 degrees. Have a look at question number 4, one part. Forces F1, F2 act on the particle of mass m. Find the acceleration of the particle. So F equals ma. F1 and F2 both are acting on it. So first I find the resultant force. For the resultant force, 2i minus 3j is minus I. For the j section, 7 and 1 is 8. So 8j. I have this, and now there is no restriction in what form we have to give ij or something else. So I'm finding the magnitude. So that is 1 squared plus 8 squared. Square root answer is square root 65. So force is square root 65. Mass is given, which is 0.25. And acceleration, so divided by 0.25 on the other side. Acceleration is 4 square root 65 meters per second square. So simply plug and play, simplify. Exam style question number 6. Two forces 2i plus 3j and pi plus qj act on particle p. The resultant of the two forces is r. Given that resultant acts in a direction which is parallel to this vector, show that. Okay, 4 marks, and it is parallel. So for resultant, we first just add them. That is 2 plus p I and 3 plus q j. It is parallel to minus 1 4. So we'll do the same thing. H times something. R is h times this parallel vector. Let me name it again, g. So 2 plus p and 3 plus q for r is equals to h times g is minus 1 4. And I'm solving these equations to find the resultant. So 2 plus p is equals to minus h on the other side. And first let me simplify this. Minus 2 minus p is equals to h. And on the y side, this is 3 plus q is equals to 4h. Now if I bring this 4 on to left hand side, I get h. Now we can substitute h into h. So once I replace, this is minus 2 minus p. Minus 2 minus p is equal to 3 plus q by 4. Now we simplify. 4 on other side makes it minus 8 minus 4p is equals to 3 plus q. Now rearrange. Taking p on the right hand side becomes 4p. Q is already there. Bringing 8 on the other side, 8 plus 3 is 11 equals to 0. Shown. Any confusion? So question 7 says, a particle of mass 4 kg starts from rest and is acted upon a force of R of 6I plus bj newtons. R acts on a bearing of 45 degrees. Find the value of b. So if it is acting at an angle of 45, we know that it should make an isosceles triangle for it to be 45. So if this is 6i, that should be 6j. So b is equals to 6. B part says calculate the magnitude. 6 square plus 6 square whole square root is 6 square root 2. Work out the magnitude of the acceleration of particles. So F equals ma. We have the net force 6 square root 2. Mass is given, which is 4. Acceleration unknown. So 6 square root 2 divided by 4 is, either we write it in exact form 3 square root 2 by 2, or in decimals, which is 2.12 meters per second square. D part says find the total distance traveled by the particle during the first 5 seconds of its motion. So it started at rest. So we have the time and we need to find the distance. So S equals ut plus half at square. Initial velocity is 0, time is 5 seconds, plus 1 by 2, acceleration is 2.12, time again is 5 squared. So 0.5 into 2.12 into 5 square is 25. Distance covered is 26.5 meters. Any confusion? Okay, when we solve questions for connected particles, especially for pulley, what we do is we write equations for the two particles. One is A, the other is B. Masses of these two are usually given. For example, let me say this is 3 kgs and this is 2 kgs. So the one with the greater mass will obviously come down and the one with the lesser mass goes up. So when we write equations for them, we know that they are connected. Acceleration on B side would be equal to acceleration on A side. First thing. Second thing, this is one rope, so the tension on both sides is equal. T is equal to T. And how do we write the equations? For A, when I'm writing for A, it is moving downwards. That means weight is more than the tension. Equals MA. What is this? That is F equals MA. I'm writing net force. Weight is downwards minus tension. So for weight, 3 into G minus tension is equals to 3A. G is known, that is 9.8. 3 into 9.8 would be 29.4 minus T is equals to 3A. One equation. And the second one would be for B. Now we know that B is moving upwards. That means tension is more than the weight equals MA. Tension is unknown. Weight is 2 times 9.8 mg, which is 19.6 equals 2, and acceleration. We have these two equations. T and A are same and unknown. So we solve them simultaneously to get the value of acceleration and tension for any other parts to be solved. Okay, so for connected particles, if a system involves the motion of more than one particle, the particle may be considered separately. However, if all the why do we consider them separately? We just draw all the arrows upwards, downwards, left and right in the same straight line. Then you can also treat the whole system as single particle. Let's consider this example. Two particles P and Q, masses 5 kg and 3 kg respectively, are connected in a light inextensible string. We can see P and Q, they are connected with light string. Whenever the word light inextensible string is used, there's no sag and there's no weight of the string. Particle P is pulled by horizontal force magnitude 40 newtons as shown, and a rough horizontal plane. Rough horizontal plane means there would be friction. Particle P experiences a frictional force of 10 newtons, so opposite direction to 40 newtons, and Q experiences a friction of 6 newton. Obviously that is lighter, it experiences less friction. Find the acceleration of the particles. Now for the acceleration, they are connected. We can solve it with one particle, and if we solve considering P, the only force towards right is 40. And there are two forces pulling it back. One is 10 newtons and the other is 6 newtons. So net force equals MA, mass 8 kgs of the two connected bodies, which is moving towards right. Towards right is 40 alone. Towards left is 10 as friction and 6 as friction. So 40 minus 16 equals MA. And you get the acceleration as 3 meters per second square. Then it says find the tension in this string. Now when we have to solve for this string, you have to consider a section. So now if I consider this section, this square in blue, may I write 40 towards right minus tension towards left minus 10 towards left equals MA, that is 5 into acceleration which we just found. So we'll be able to solve for T, which is minus T equals 5 3 times 15 and 40 minus 10 is 30, minus 30 on the other side, so minus t is equals to minus 15, which is t is equal to 15. Let's try it with q. If we solve for q, the only force which is going towards right is t, minus 6 which is towards left equals m, and acceleration was 3. So t is equals to 3 times 9, take 6 on the other side, that is 6 is 15. So you see, whatever you consider, you get the final answer which is same. So this was the thing which they highlighted, that once they are in same straight line and they could be considered separately. Another example question. Let's solve this question. Exercise 4E, two particles P and Q of masses 8 kg, 2 kg respectively are connected by light inextensible string, means no mass. The particles are on smooth horizontal surface, no friction at all. So let me consider these two particles which are connected, P and Q. This is P, this is Q. 8 kgs and 2 kgs. A horizontal force of magnitude F is applied on P in the direction away from Q. So this is F away from Q. And when the string is taut, no sag, and the particles move with the acceleration of 0.4 meters per second square. Acceleration is already there. So find the value of F. So F equals ma. F is net force. Forward force, because there is no friction, it is smooth. So F equals mass, total mass, because the force is pulling 10 kgs with an acceleration of 0.4 multiply. So F is 4 newtons. Find the tension in the string. Now when we find the tension, we consider one object. We consider this box. And I'm talking about particle P. We have just seen that we solve it with P or with Q, we do get the same answers. So I'm just considering particle P in this case. When I consider P, I see the forward force moving towards right, which is 4 newtons, and I can subtract this tension. So that is net force. F equals ma. Net force is equals to mass of P is 8 kgs and acceleration is given in the question, that is 0.4. So 8 into 0.4 is 3.2. 4 minus t, we rearrange. 4 minus 3.2 is 0.8 and take t on the other side. So tension is 0.8 newtons. It is so less because the surface is smooth. C part says explain how the modeling assumption that the string is light and inextensible are just used, which we just discussed. Light means no weight and inextensible means it is just taut. There is no lengthening of the string.